Hi everyone, welcome back to the channel. Today's we are going to discuss about the NumPy and we'll go from fundamental to the advanced technique. So whether you are a beginner or looking to refine your skills, this video will help you to cover the core concept in the NumPy from basic to the advanced techniques. So by the end of this video, you have a strong understanding of how to use NumPy for high performance numerical computing. So let's dive in. So first thing first, what is NumPy? So NumPy is short for numerical Python. It is a powerful library that provides support for large multi-dimensional arrays and matrices, along with the collection of mathematical functions to operate on these arrays. It is a backbone of scientific computing in Python and is widely used for data analysis, machine learning, and more. Now to start using NumPy, we import is as NP. So let me import the NumPy, which is the convention in the Python community. Now at the heart of the NumPy is the array. An array is a NumPy is like a list in Python, but much more efficient for numerical computation. So let's see how to create a NumPy array. To create the array, we call the library NumPy.array as the function and pass the number of element in the array. So in this case, I'm passing just 1, 2, 3, 4. And if I print this, I get this the array. Now this is a one dimensional. We can always also create a two dimensional or multi-dimensional array. So let's create a two dimensional. So again, this is same array and there are two dimension to it. So first one is this, second 4, 5, 6. And if I print this, you can see this is a two dimensional array. So you can create array from a list or nested list. In this example, AR is a one dimensional array while ARR2D is the two dimensional array known as the matrix. Now let's see the array properties. So NumPy array has some useful properties. Let's check them out. So the first one is the shape of the array. That is the dimension. So if we run this, we get the shape of the array ARR, that is the one dimensional. It has four elements. And the second one is it has two rows and three columns. Let's check the total number of element, that is the size. So the first one has the four and the second has the six element. So that is the size of the array. Now let's check the data type. So those are both int integer, right? Integer array. And the next one is let's check the stride, so memory layout. So if I run this, so I got A24T. So the shape, the first we see is the which tell us the dimension of the array. The second size gives the total number of element in the array. The D type gives the data type of the element in the array, and the strides which tell us about how many bytes are needed to move to the next element. Now let's also see the array operations. One of the most important, the NumPy strength is ability to perform element-wise mathematical operation. So let's see some examples. Let's create a new array of array 3 and we can um, do the addition of one array into another. So if I run this, it the AR, the first array which we created earlier, got we added with the this array, and that's how the element-wise operation happens. First element of ARR with AR3, and that's how this is the output. Next, let's do the scalar multiplication, multiplying 2 with each element, and this is the exponential of the each element of the array. We can also sum the array, like calling the np sum function and pass it. It will give you the 10, that is the output. We can also calculate the mean of the array like this. Next, let's see the array indexing and slicing. So just like Python list, NumPy arrays support indexing and slicing, but with more powerful functions, right? You can slice multi-dimensional arrays too. But remember, the array index begins at 0 So this means the first element of the array is at index 0 and the second is at the index 1 and so on. So if I print this, so this gives me the 3. So that is the third element 0, 1, 2. 2 is the 3 in the third array in the ARR array. We can also slice the 3 is not inclusive, so it will give you the 1, 2 means 2, 3 as the output. Similarly, we can do with the 2D arrays, it will be the same output. So this is the slicing of the rows, this is slicing of the columns. So if this was our array, so it goes to slice the first, right? And 1, 2, 3 means this one. So this is the output we got. Now let's create one more array and I want to show you this example which is more clear. So we have created one array 1, 2, 3, right? So data 0 means this is the first element, this is the second, this is the third, and it's always start with a 0. If we do the slicing 0 to 1, where 2 is not inclusive, so this is not inclusive, it's give you the output 1 and 2. If we start with the 1 to the end, 1 to the end, 2 and 3. Minus 2 if you start counting from the back end, from the backward, so it will like minus 1, minus 2, so on. And if it's give minus 2 to all, means it will give all the 2 to 3, right? And this is the again the same representation, start with 0, 1, 2, 3, and it is minus 1, minus 2, minus 3 like this. Next, let's talk about the advanced operations and the first in the broadcasting. So NumPy also has a powerful advanced operation. These includes the broadcasting, linear algebra function, and random number generation, and so on. So the first one is the broadcasting. So broadcasting allows NumPy to perform element-wise operation on array of a different shape. So in this example, we are just we created one array data 1 and 2, and we are multiplying it by 1.6. So it is element wise, it will just multiply these two and give you this output. So if I multiply this array with minus 2, it gave 1.6 into 3.2. Next, let's talk about the linear algebra. So NumPy is also support linear algebra operations like dot product and matrix multiplication, which are crucial in the machine learning and the scientific computing, right? So let's create two vectors, and here I'm performing the dot product of vector 1 and vector 2. In the next example, I'm just doing the matrix multiplication for matrix 1 and matrix 2. So you can use matmul function from NumPy to perform this operation. Next is the random number generator. So you can use the np random randint function. So it will produce the number between 0 and 10 with this matrix size of 2 by 3, means 2 rows and 3 columns. And every time it's random. And finally, I would like to show optimizing with NumPy. So one of the biggest reason to use NumPy is its performance. So NumPy's array are faster than uh, Python list for a large scale numerical computation, and thanks to their fixed size and efficient implementation. So let's compare the performance between the NumPy and Python list. So if I run this, this is 10 millions record, and I'm just multiplying it by 2. And let's see how much time it takes. So it took around the total CPU time is 1.33 seconds, fall time is 1.3 seconds. And let's do the same operation for same number of elements in the as the part of, I'm just creating an array. It took almost like 1/4 of the time, or more than 1/4 of the time than what the Python list did. Yet, so you will often notice the NumPy operation are much faster than equivalent operations on a standard Python list. especially when working with a large data set. So that's a wrap up of the comprehensive guide to NumPy, from basic to some of the advanced techniques. So NumPy is a fundamental tool for anyone working with numerical data, and mastering it would make you a data science and make your data science and the machine learning project much easier and faster. So thank you for watching. I will see you in the next one.